So thank you very much, Maxime, from China Electric. So maybe before we start talking about what you're doing at the edge, can you maybe explain what is the edge in a very few words, just in case not everybody in the room knows what it is?
So we can basically fill the full Wikipedia page with it, but for the sake of this session, we will use Edge AI as AI running in physical devices, which are in a factory floor shop, which are in a building. So mainly focusing on how models are inferring inside our products, like industrial PCs, programmable logic controllers, or on the other end for energy management, automation server, room controllers. So that's what I would propose for Edge AI. So AI running on physical devices that are on-premise, close to the process, close to the users.
Okay, so there's obviously a lot of different edges, but this is what we're going to be discussing on during the next 15 minutes. So may I want to ask you before we go into the use cases in terms of if you're a company, you want to start running stuff on the edge AI, what is kind of the main motivation and criteria when you're making a decision? I mean, there's a lot of people talking about sustainability, efficiency, security. Are there the main three? Are there any others? What are you seeing?
We can take it as the same analogy between the IT technologies and the OT, operational technologies. So when we go on the field, it's because we want performance, we want reliability, we want not to depend to an external network, we want to have low latencies. So I would say the first aspect is this one, because if I take the example of building management, you don't want to wait for HTTP request to come back to have the light switched on. So you want to enter and the light is on. So you need low latency. That's happened in the edge that doesn't can travel all over zone. Second aspect where we take care of is sustainability. In data processing, the main energy is consumed by moving the data from one point to the other, moving the data from a local physical space up to the cloud, computing and come back. The big part of energy consumed is for moving the data. If we compute as much as possible directly where the data is measured, we save all this energy. And also we save money. So we optimize the total cost of ownership of the solution by enforcing also the sustainability of the solution. And the last aspect that we have in mind is when we avoid having the data traveling all over the cloud, we don't expose this data. So we enhance naturally the security of our systems. So basically, performance by having more robustness and low latency, more sustainability and reducing the total cost of ownership, and cherry on the cake, security is enhanced by not exposing the data over travel.
So quite a lot that can be done, and that is kind of more precious to the edge. So what exactly are you using it for? What are the key use cases? I think, as we limited already, sometimes we talk about the technology, but the technology needs to fit what are the use case. So maybe start with generally, and then I know you've got a great example in terms of building application that you want to share. So I'll let you do that.
Yeah, so at Schneider Electric, we focus on the value that we can deliver to our customer. So we have several applications, but if we take the building segment with the building application, it's an important one. In Europe, 40% of the energy which is consumed in a building for a building. And in a building, I would say a good half, between a third and two-thirds of the energy consumed by a building is for HVAC, so heating, cooling, and the ventilation for the comfort of the people which are in this building. So when we see the amount of energy used by the building, and if we can, by adding some local intelligence in each room to better use this energy, so meaning reduce energy by better comfort of the people inside, we have a huge lever to reduce the CO2 impact of our activities in buildings. And that's what we do. So we don't oppose cloud and edge. For large buildings, we have a building management system which largely rely on cloud application and which already runs AI in the cloud. That has helped us to develop model that understand the behavior of a building, the behavior of the rooms. And what we have recently done is we have leveraged all this domain expertise in a small device, which is in each room. So we call it a room controller. Basically, it is a device in charge of turning the light on and off, open or close the blind, demanding more ventilation or more cooling, depending on what happens. So you can figure it out like a smartphone format device, a little bit thicker because it has sensor in it to measure CO2, to measure temperature, humidity, and also some presence detection. And inside this device that are taking care of controlling the environment of a room, we added AI-based model to better understand what is happening in the room out of the physical parameter, and also to predict what kind of set point will be needed depending on what is happening now. And what I said at the beginning, so Edge AI is mainly about inference. In this case, we allow ourselves not to train a model in a room controller. No, that won't be possible, but to fine-tune some parameters. So we have this model, which every day is taking control over the room and learning, fine-tuning some of these parameters week after week, so that we are able to reach a better target in terms of comfort, by reducing the energy consumption from 5 to 15% in some cases. So that's the kind of complementary approach where we first used a cloud AI-based solution to understand big buildings, large buildings, and out of this domain expertise, we put into our product an AI algorithm to deliver more value, meaning more comfort, less energy consumption. And this in a form which is also suitable for a retrofit of building. The another point, buildings, they are consuming a lot of energy, and they are here for a long time. 85% of the buildings in Europe are older than 25 years old. So if you remember, year 2000, we were believing that a computer could stop at January 1st, and your smartphone was a kind of a desktop and a PDA and a cell phone, and you were trying to take some notes. So the kind of technology we had in the building back to this time was not even thinking about reducing the CO2 footprint of a building. And this kind of development, by having it at the edge, running almost autonomously without any network connection, you can retrofit, meaning you can take the actual old building and reduce the energy consumption by using this kind of technology. So it's an example that we love at Schneider because it's an example where we can see that technology that is already available today can already have a big impact in terms of CO2 reduction.
Yeah, and I mean, obviously there's a huge addressable market, as you mentioned, lots of old buildings. HVAC is a lot of energy. You mentioned the kind of 5 to 15%. Do you think going forward that could become even better in terms of how much you can reduce, or is it kind of almost a limit in terms of you can't go beyond that?
When at Schneider Electric, when we go into this consideration, we try to do it scientifically. So this 5 to 15%, it is out of a study that we are doing. We have a so-called Schneider Research Institute. A Sustainability Research Institute, which is working with universities and a lot of academics and standards to check what we are taking as assumption or what we are claiming as benefit. So that's why I'm not able to predict where it will go. But if we take today this 5 to 15% energy savings on all the existing buildings, we already are addressing a small half of the energy that we are consuming in Europe. Mm-hmm. So the gain maybe seems small in the percentage, 5 to 15%, but it's addressing a big part of the energy consumption that we have today.
Yeah, so even if it seems small, it's actually quite a lot. I kind of want you to go back to something that you mentioned in terms of when people talk about the edge, they see it as opposite to the cloud, when kind of, you see it there, the cloud there. You mentioned that in your perspective, they're complementary. Yeah. Can you maybe expand a bit deeper on that? Because I know you've got some stuff in the cloud, stuff on the edge, they work with each other. So it'd be kind of interesting that the people in the audience don't have kind of a binary perspective in a sense.
At Schneider Electric, we are very proud of our product portfolio. We are a product company, so we are acting in the physical world, on the field, on the shop floor, with our product every day. thinking that all this will become connected to the cloud permanently and rely on a central large model that will decide for every application in the planet won't fly. So that's why where it makes sense to use a centralized system when we are dealing with building management system, large buildings, we have a huge amount of data. So of course, cloud and AI in the cloud is the right one. If we go down to the room and we want to smarter control a room, we don't need huge compute resources. The one we already have in our product with smart algorithm inside is already capable today to deliver this value. That's how we see. So we have a legacy in products. We have we love to call it the best things in energy management, and we see how we leverage our AI capabilities that we are building on top of it to have our product future ready to better serve our customer.
I want to open it up to questions. So do we have any in the room? Please don't be shy. I will call you out. I'm French. I have the name of a serial killer. I'm very bad if I want to. Please. No? Really? You see, we should have done it in Sweden. Anyway. Oh, we got one. Sorry. Yes, go ahead.
Connor White from IKEA. Great use case on building. We have a big portfolio of buildings, so we're looking at some of this tech as well. But I was just thinking that from the perspective of the big contributors to energy and how we can optimize that using the mix of central cloud and local intelligence at the device level or the room level. I've noticed, for example, there's a huge growth, for example, in EV charging, and we're seeing that grow as a percentage of household energy consumption. And EV charging also being a potential solution to stabilizing, a smarter grid. Do you see this as that kind of use case of optimizing EV charging at a lower price point if you're spot pricing, or using EV vehicles more generally to stabilize the grid using a mix of cloud and edge compute?
Yeah, indeed. And we have a solution which is called Home Energy Management System, which is exactly dealing with how many my solar is producing, how is the charge of my electrical vehicle, what is the price, what I can get from the network, and which is making the right balance between reselling the production of the home to the network, or directly charging the vehicle, or taking back from the vehicle to power the house when the network prices are too high. So this kind of application is very specific because it depends on the regional laws. So we have a good example, which we always take the California with Title 24, and how things need to be optimized in order to reduce the impact of the houses on the network, or some other in the DAC space, so the Germany, Switzerland, and Austria, where this self-production of energy has started a couple of years ago.
Anybody else? We've got a minute to go. Otherwise, yes, gentleman over there.
I'll just say.
Yeah, please.
So back to products and things to users. I'll give you an example with cameras for traffic monitoring or something like that. They often have embedded AI. And I wonder if you could comment on maybe the convergence of hardware to support AI models on the edge, and AI models that support being put on the edge, and where that market is going to go and who's going to own those products.
So if I understand the question right, it's about the evolution of the hardware supporting this embedded AI and the evolution of the application we want to do with that, like we can see in the cameras, where always more signal processing is done in the camera itself.
And what that will mean for the market and the players in the market. So will we see more adoption of AI by smaller manufacturers of, say, just cameras?
if I come back to the Schneider Electric perspective, in most of our core application, we use AI embedded as a very powerful signal processing to better understand mainly voltage and current signals that are the core of the business of our processes. What is fascinating is that even with the resources that we have today in our product, there have been a huge gap in mathematical methods that are allowing us to run even a deep neural network, strongly quantized on small existing microcontrollers. When I say small, it's microcontrollers that cost less than $3. So even for this very, very small machine, we are able to use advanced mechanics thanks to, I would say, the progress in mathematics and the progress in compilation environment that we can use for microcontroller. It's a very, very specific field. So it's trying to do AI with the resources that you have in the computer mice. That's almost the challenge in this area. And we keep an eye on it, and we are part on ecosystems that are working on it.
And I'm afraid that's all we have time for. So thank you very much to Maxime for a very, very interesting conversation.
Thank you for having me. Thank you.
Thank you. Merci beaucoup. Merci.